So as indicated by Claire, the focus of the panel today is on the future of energy research in Ireland. And it's the second such panel I've had the privilege of hosting. Last year was actually looking down a computer screen at everybody, so it's great to be doing it here in person. And in preparing today, I reflected back to where we were this time last year, and we had just had another IPCC report stating the need for deep reductions in CO2 and other greenhouse gas emissions over the next decade. We had countries at the COP26 summit signing up to more ambitious carbon emissions reductions, and including a testament from our own Taoiseach to becoming climate neutral by 2050. And importantly, in the context of this discussion today, acknowledging the important role that science and technology would play in achieving climate neutrality. 1 year on, and we're in the midst of, as we all know, a global energy crisis due to the war in Ukraine, which has really highlighted the fragility and unsustainability of our current energy system. The COP27 summit has just happened once again, and that has highlighted, I guess, the importance of achieving that 1.5 degree target. Many would say we haven't gone far enough, and that would be kind of backed up by reports from the UN Environment Programme, which says there's no credible pathway to reaching the 1.5 degrees target currently in place. So it really speaks to the importance, the urgency of addressing this problem. We heard Campus Engage, Kate, talking about our wicked societal challenges, the need to move more quickly in this area, and research and innovation, as we know, has a critical role to play. We really need to accelerate efforts in this area. And this involves bringing together many different stakeholders, not just researchers, bringing in government officials, bringing in the public to really make a change in this area. So that's the purpose, the backset to the discussion today, and we're joined by some leading researchers in the area, and the overall goal is to talk about research in the area and to really inspire and excite people to get involved. So just to introduce the panel first, so we're joined by Professor Andrew Keane, who's Director of the NexSys Partnership, and also from the Director of the Energy Institute at UCD. He's a professor in the School of Electrical and Electronic Engineering, and he has research interests in the area of power systems planning and operation, integration of distributed energy resources and distribution networks, and really looking at the main challenges that lie ahead in transition to a smart grid, which is a major focus of the NexSys partnership. We're also joined by Hannah Daly, Professor Hannah Daly from UCC. She's a professor in sustainable energy and is a PI in our MaREI Centre for Climate Energy and the Marine. Professor Daly leads research focusing on achieving rapid sustainable climate mitigation pathways. And last but not least, welcome Professor Kevin Ryan. He's chair in chemical nanotechnology at the Bernal Institute. He's a PI in our Amber Material Science Centre and also a PI in the MaREI Centre, with research interests in the area of nanocrystals and nanowires, with an emphasis on synthesis, assembly, and device applications in ICT, energy storage, and energy conversion. And I'm delighted to be joined by you today. So I might move over here before I start. So Andrew, the energy sector, as we know, is responsible for over 3/4 of the greenhouse gas emissions, which really speaks to the requirement for a complete transformation of how we produce, store, and transport energy. And can you talk to us maybe about the work that NexSys is doing with respect to decarbonising the energy system?
Sure, thanks Siobhan, and it's a delight to be here. Yeah, you're absolutely right. So the energy system is responsible for a lot of the greenhouse gas emissions, and what we're seeing really now is a great era of electrification. So as per the Climate Action Plan, right, we're going to be electrifying as much of our energy as we credibly can. And happily that's because we've seen a great development of technology in the electric space over several years. And of course it's all connecting it into the grid, which there's been a lot of focus on of late in terms of our energy security. In terms of the Energy Institute and NexSys, and even over several years, we've done a lot of research looking at how can we increase the penetration of renewables onto the grid. So we're seeing a shift from what was an electromechanical system, a lot of steam turbines, right, driving the system, to an integration of power electronics. And when I think of power electronics, if you think of a wind turbine, electric vehicle, heat pump, solar panel, you name it, there's a power electronic inverter between that and the grid. Which introduces great opportunities for instability, also a great opportunity to be properly controlled and actually to aid the integration of renewables onto the grid. So in Ireland, as an island, as Kate outlined quite nicely, on the northwestern edge of Europe, we have a grid that's somewhat isolated, so we need to manage basically our own affairs from an electrical perspective. And the happy story really is that we've achieved, as a system, kind of world-leading penetrations of wind energy onto the grid. So if we look at our 2020 targets, the electrification one was the only one that we actually, I think, just about achieved 40% RESI. That's reflected in what's going to be coming next in terms of if you look at the targets towards 2030, highly ambitious targets for electrification, and I think that's appropriate. And a lot of the research we've been doing in NexSys and in UCD has been around the stability of the grid. So working with our grid and working with industry to enable in real time more and more wind energy to be permitted on the grid. So we've moved from a situation where I think it was around 50% at any given time would be the maximum amount of wind energy that we would allow on the grid to towards 70, 75%. And that's underpinned by analysis from ourselves and others around the stability of the grid, that they're happy that they can safely interconnect that onto the system. So we see that on the supply side, and then on the demand side, as you mentioned, smart grid, we're seeing a great, well, hopefully, uptake of electric vehicles from my perspective and heat pumps, but I think they are the technologies that will work, or at least that's what the efficiency and thermodynamics will tell us, and then there's a great opportunity there in terms of demand flexibility to, as I say, integrate it onto this grid, which is kind of common interconnecting infrastructure. So there's some of, I guess, the highlight topics.
Okay, great, thank you. And Hannah, I might come to you next in terms of, kind of, I suppose, coming at it from the MaREI Centre and the focus on renewable energy and sustainability. What area of MaREI's research do you say making the most immediate impact?
Thanks, Siobhan, and thank you for having me here. I have some wonderful colleagues in MaREI who work extensively with industry and with society, but the area of work that I'm mainly focused on, and my research topic is engaging with policy. So we build energy systems models to help develop the evidence base that policy can bring about the radical changes in our energy system that are necessary to stay within our carbon budgets. So we have a politically agreed carbon budget program which should put us on track with our climate commitments globally. But the tools to actually understand where societal and technological transformations and institutional transformations need to happen, we do a lot of the underpinning work to develop that evidence base. So for example, the energy systems modeling work that we do, it links energy supply, transformation and demand to build somewhat of like a map. I see these models as like maps. They're projections of the energy system for decades in the future that show a quantitative basis for how these systems might change or need to change. And one example of the engagement that we did with the policy system was last year. As part of the statutory process in the Climate Act, the Climate Change Advisory Council advises the government on carbon budgets that are consistent with the Paris Agreement targets. And I worked extensively with the Council in their Carbon Budgets Committee to model the impact of different carbon budgets on the energy system, to show that the carbon budgets that were eventually adopted are technically achievable. I say technically because many of the measures that are necessary to achieve those carbon budgets may not be politically feasible, may not be societally feasible, but we know that there are pathways that add up to meeting those carbon budgets. Unfortunately, greenhouse gas emissions this year are still rising, so even that technical feasibility is starting to be in doubt. Another piece of work that we're doing for government is for the Department of Public Expenditure and Reform. So one of the critical inputs to the decision around public investment in infrastructure like roads or rail, these investments have to go through appraisal to understand not just the costs and benefits to society, but also the cost of carbon. And there is a marginal cost of carbon that is part of that public appraisal process. And previous modelling from MaREI underpins the current cost of carbon, given our old climate targets and so on. And we're doing work to update that valuation of carbon in the public spending code. I won't reveal what the results are at the moment, but the number, the valuation of carbon, the cost of carbon is going to go up hugely significantly, and that will have a big knock-on impact on what public infrastructure goes ahead in the future, which is consistent with our climate goals. And then a third piece of work that we're doing, a PhD student that I work closely with, Ankita Gower, we often focus very much on the supply side, which is really necessary, looking at the grids, looking at storage, but we also know that we can't meet our carbon budgets with a focus on supply alone. We also need to look at how we use energy, what technologies we use, and what actually underpins our hugely carbon intensive and energy intensive economy and society. And so my PhD student, together, we've looked at a low energy demand pathway for Ireland. So what if we build our economy, our transport system, our heating system in a way that we don't need so much energy? And it shows that it brings many societal benefits, lowers the cost of the transition, and relies less on these kind of radical transformations on the supply side.
Mm-hmm. Great examples of research underpinning policy there. Kevin, if I come to you now and kind of as a PI in the Amber Centre, where there's a very strong focus on materials for energy to take a different perspective to this, and where there's a focus on mobile applications such as energy storage, looking at novel magnetic and thermoelectric materials for different energy solutions. Can you briefly talk to us about the research that's ongoing in Amber, and in particular your own work in lithium-ion batteries for electric vehicles?
Yeah, absolutely. Yeah. So, I'm, I suppose, very much involved in nanoscience research. So I suppose we had from the first talk this morning, when you, I suppose, make materials at that little scale, what they can do that they can't do at the bulk scale. And so in our work, we work on new materials for lithium-ion batteries for electric vehicles. And if you take a material, for example, like silicon, if you took a piece of silicon and use it as an anode in a similar form that, let's say, graphite is, it wouldn't work. Essentially, you can only get one charge, and the material expands so much when it takes up that lithium that you'll only get one cycle. But if you can make that at the nanoscale and make a lot of those in nanowires, and it's nanowires that we make them, then it's able to withstand that cycling. And we've been able to show that you can get over 1,000 cycles with this material. And what that allows you to do then is to ultimately, when you apply that in a lithium-ion battery, then you can get a dramatic increase in your energy density, which means your range, it means your fast charging. And so we're, I suppose, taking the fundamental research on these materials and then applying that at scale. And so we're not just doing the fundamental work, but we're also at UL, and I'm PI on two European Horizon Europe projects, Horizon Europe and Horizon 20, in the area of applying these to electric vehicles. So we're linked in with partners that work on the electrolyte, on the cathode materials, and then also on the scale-up of the batteries. So we're working right through to the industry like CRS, Stellantis and Ferrari in the application of the batteries in EVs. So there's a nice kind of combination there from the fundamental science right through to the application.
Mm-hmm. Great, and you can certainly see the opportunities for collaborating across all of these areas. So this comes back to, I guess, the call to action today around getting more collaboration in the area. And if I come back to you, Andrew, in terms of NexSys, where you've built not only a Republic of Ireland, but an all-island collaboration involving kind of several research institutions, several academics, also government and industry stakeholders to really tackle this very challenging area. How important has that model been, and how successful do you think that overall approach will be?
Yeah, really important, and I think Kate described it beautifully earlier. I won't try and rehash it, but completely subscribe to what you were talking about, Kate, in terms of that approach, that partnership approach, and that impact on society and the societal dimension. So as an engineer, I'm all into the technology, absolutely, and developing the new technologies, but equally there's a huge societal dimension, of course, to the energy transition. So in terms of the partnership program, indeed, it's all island, and so the grid, right, the energy system is an all island grid, so the physics of the grid don't particularly care about borders or boundaries or anything like that. And equally, it's also an industry academic partnership. And if we look at industry and look at what they're doing, and when I say industry, I mean it in a very general sense, they oftentimes are tasked with a lot of the actions, and the Climate Action Plan will be tasked with a range of actions to come. And so without all those voices, let's say, in the room at the outset of a program, I'm not sure we're going to get to the kind of the outcome that we need. And the energy transition is one example, I think, of a complex and wicked problem that requires this approach. So for me, it just seems to be the correct approach. And happily, I think I would say that in terms of the RPOs, the research performing organizations, and indeed the industry partners, and industry can be tricky, right? You want good industry partners, and all our industry partners happily weren't just interested in some kind of short-term contract research, and there's nothing wrong with short-term contract research, right? They were subscribing to it very much around the idea of a partnership coming together. And it seemed to me in the formation of the partnership that actually we were providing a forum for industry and academia to come together in a room and actually have a genuine dialogue around kind of, as Kate was talking about at the outset of the program, getting engaged research underway, which I think gives a much better trajectory towards success.
I certainly heard Mark Foley from EirGrid speak very passionately at a Shared Island Unit event recently about the importance of working together in this area. In terms of Hannah and Kevin, you're also involved in large collaborative initiatives with a slightly different model, but from your perspective and in terms of trying to get more researchers focused on this area today, what are the areas that you think still need to be addressed through this multi-stakeholder engagement? And Hannah, I might come to you first.
Thanks, and I would say that there are still large technical challenges on reaching absolute zero emissions, in the long term. But in the short term, what matters for the climate is every ton that we avoid adding to the climate at the moment, and we are in a climate emergency. Things are very bad. And the thing that I've come to realize is that we really do have all the technical solutions that we need to radically cut greenhouse gas emissions this decade to meet our carbon budgets, but they're simply not being deployed. And so the question that we as scientists and engineers and people focused on the energy system, I think, need to understand is what are the barriers to the rollout of these solutions, these electric vehicles, renewable energy and bioenergy and so on, that already in many cases are cost effective. There's many EVs which are cheaper than the typical new car that's bought and bring large societal benefits, cycling lanes, and solar panels with the cost of energy crisis. They're not being deployed quickly enough. So I think in terms of increasing the impact of our work and really driving the energy transition, we need to work more with humanities to understand what are those barriers to deploying the solutions already, because it's not just about kind of a clean energy transition, it's also about, frankly, it is about phasing out the fossil fuel industry, which generated profits of $4 trillion this year. So there's very large barriers to scaling that down, whether it's institutional, it is matters of power, it is about psychology and so on. So we need to understand what these barriers are. So we need to kind of cross campus and speak to our colleagues in political science, and social science, and the humanities, and so on. That is one thing that's necessary to bring about those large scale transitions. But we also need to understand, as I said, not just about how we supply energy, but how we use energy. And people have to be involved in the energy transition. People have to make decisions to change how they use and how they supply their individual, their house with energy, or their cars and so on. And people experience change as a loss. So even though many of these energy technologies bring wider benefits to individuals and to households, people do experience change as a loss. And so it's again, we have to understand how to bring about that change in a way that people and societies kind of come along with the energy transition.
Mm-hmm. And where MaREI are doing quite a bit of work in the Dingle project, as an example, in that area.
Exactly.
Kevin, if I come to you now with the same question.
Yeah, so certainly the collaboration is hugely important. So I would see where you have, like, for example, scientists working together with engineers. And I think back to, I suppose, the earlier example where you're able to work across multiple TRL levels. And like, if I give an example of that, like one of the areas where we've started working now, and again with our colleagues in electrical engineering at UL, is in terms of the second use application of batteries. So when a battery, and you think of an EV, comes to the end of its life, you can still have 70 or 80% of the available charge remaining. Now, that may no longer, in actual fact, we're actually seeing now where the batteries are outlasting the vehicles. Mechanically, the vehicle is gone, but that battery still has a lot of value. And if you can reapply that battery for stationary storage applications, then it helps to solve the issue of having storage on the grid. And so we're starting to work with not just our colleagues in engineering, but also with companies. So like we were working with EirGrid and also Analog Devices, because you you need the technology to be able to look at the state of health of that battery. And I have a colleague, Dr. Todd Kennedy in UL, also working on projects on that to be able to make sure that second life battery is safe, and also that it can maybe get another 20 or 30 years out of that. But we've, I suppose that's examples where you need the science, you need the engineering to be able to deliver on those projects, but it also solves a large-scale issue for Ireland, because as nationally we will have an issue with the EVs that come to the end of life, because there's nowhere on the island where we can actually recycle those batteries. So if we can actually keep those on the island and repurpose them for use on the grid, we're actually solving a national problem.
Fantastic. In terms of then, for all of your initiatives and the call to action for researchers today, how do they engage if they want to collaborate in new areas as part of these different consortia?
Yeah, well, so NexSys is very much open for business and engagement, as we have been. And in terms of, I guess, multi and transdisciplinary research, I mean, our experience has been there's an overhead to it, right? It takes a lot of time, it takes a lot of conversations, but a sustained conversation can really deliver those benefits. Okay. There's a language barrier between disciplines, even within engineering and science, right? But also with the social sciences, as Hannah talks about. We're working with a political scientist now in UCD, also environmental psychologists. And there's probably a huge language barrier, but over time, it really does deliver that fruit, I suppose, would be my remark. So I would echo the call to action here for sure.
It's interesting. We had a panel in last week, and they were talking about how you work with different disciplines. And they actually, when you talk about that language barrier, where they brought in a translator, and that was the really effective part in getting each other's language across. Before we come to questions from the audience, I guess I have one final question for the panel, and it comes back to the theme of this week's Science Week, which was to explore the infinite possibilities of science. So the question is there any research on new energy sources that maybe, while it may still be quite far away from realization, and maybe previously was considered something completely impossible, but now looks promising?
I think Seamus gave us a nice introduction to superconductivity. So there is now an Irish company trying to develop a commercial scale superconducting transmission technology. So the promise, as outlined there, of a zero resistance, high power transfer capacity is huge, as is fusion, of course, but these are far away technologies. Maybe floating wind turbines in the relative nearer term probably holds a lot of promise, but I'm sure my colleagues have thoughts too.
I mean, I'm hugely excited that renewable energy is now the cheapest form of electricity in history. So I'd say we're almost all the way there, which is fantastic news given where we were maybe 10 years ago. But I'm going to give a very boring answer, and I think that the most sustainable form of energy is the unit that we don't use. So understanding how we can use less energy and still reap its benefits, it's the real exciting challenge.
Absolutely. Gavin?
Yeah, so I suppose for me, and look, it does come back to, I think, having storage and storage as a solution. But like, if I look at some of the technologies that potentially have a that could potentially make a huge difference, and let's say, obviously, we've seen the lithium ion in batteries, but lithium ion isn't going to be a solution for everything. And if you can, for example, get sodium ion and potassium ion, which are a lot cheaper ion sources, and if you can make a battery from these systems that has the long cycle life, then you really get to a possibility of having storage on the grid, and technologies around that. And there's a lot around in terms of solid state electrolytes as well, which is another big area. So I think that pulls together a lot of the big expertise in Ireland in material science to try and solve these problems. And if we can get there, then it does have a very large impact.
Great, thank you. So we have a variety of questions in here from the audience. So I'll come to the bottom one here. Does the panel see a long-term role for farm-scale anaerobic digestion in Ireland's decarbonised energy system? I don't know. Does anyone want to take that?
I might quote the wonderful Professor Jerry Murphy here, who's the expert in this. But anaerobic digestion is a great solution for cleaning up the farm system, so making use of slurry to produce a byproduct which can be valuable in our energy system. And in our energy system, every additional bit of renewable energy is extremely valuable in our energy transition this decade. The role of whether we dedicate more land to producing grass with potentially extra fertilizer in order to feed into making biogas, for me, it's a question of what the best use of that land is for. And there's an ongoing land use review which looks at, whether the best use of land is to produce energy, to restore nature, we're also in a biodiversity crisis, to produce food, or to produce a carbon store by re-wetting or reforesting the land. And that will depend on every individual bit of land. I think that land use review will be very impactful, but certainly as part of a circular economy in the food system, anaerobic digestion will play a part. Yeah.
Mm-hmm. And it comes then to the engagement with end users and the various communities that are impacted here. And we have a question here about how important is engagement with energy end users, citizens in the energy transition? Is the problem not partly a social science problem? So maybe, Andy, do you want to take it?
Yeah, it absolutely is a social science problem. Yeah, so I think as hopefully we've been commenting, that's a huge element of the transition. So one example, I suppose, from our research, one of my colleagues, Dr. Herta Schutema, has been doing work in the Midlands with communities affected by the closure of the peat power plants. So again, objectively, yes, the peat power plants must close as part of our emissions reduction, makes sense. But of course, there's communities affected. And the findings from their engaging with the communities, as Gertrude would call it, data gathering, is a real level of cynicism on the ground around just transition, just being a word that's trotted out. And also, but then also allowing Gertrude to put a structure around what does a just transition, or what could a just transition look like, to hopefully build trust. So if we get those kind of things wrong, then we're not on the path to success. So one quote I would add, right, which is, we got the medical science right on COVID, maybe the social science. I think Ireland may be an exception, and I'm not just saying this because Philip's in the room, right? But I was in the US recently, and I don't think they got the social science right in terms of COVID, right? So I would hate to see that transferred into what's going to happen with climate change over the coming years.
Can I follow on from
Sure.
that? Yeah, I think there's really great parallels with our what we need to do with climate change and our response to COVID, which was very successful. And in large ways, the challenges are parallel. They are about protecting vulnerable people. So I recently was at the UN climate talks, saw the minister from Pakistan, where 33 million people are displaced from floods, talked to people whose islands are disappearing and so on. I think that politicians and people working in the energy space need to be clear that we're making this energy transition in solidarity with those people, and that is the urgency. And in Ireland, we have great trust in scientists, people have trust in institutions, and there is great social solidarity, and I think those messages need to be emphasised by policymakers. But first, leaders have to lead. People aren't going to take the necessary measures to decarbonise their own lives or industry unless they believe that the leaders in society are doing it first. And I think that is crucially important. During the pandemic, the heads of the political parties came out with without haircuts. It was very clear that they were taking these measures first. And also, I think that the trust in scientists, trust in institutions is very important. Yeah. Thanks.
Absolutely. I think this is another question for you, Andy, with regard to the Ireland's electricity grid. Is it stability or capacity that's the current bottleneck, and how should we best improve that?
Yeah, good question. It's both, basically. So I guess the best way I could put it, if you look at what airgrid happens now at wind, there's two reasons they curtail wind, right, which is reduced the wind output. One is around the stability limit on the grid, and we need to overcome that and have been making successive progress on that. The other side of it is around congestion, or I think a capacity limit on the grid. So, we just haven't built out the grid to meet, I guess, the development of demand, and that's partly why we are facing some kind of more local energy security issues in recent times. So, yeah, the short answer is both.
Okay, I think we have loads of questions coming in here, but I think there's time for one more question. In terms of what role do the panel see increased activation of demand response playing in decarbonisation of the energy system, and how can rollout be increased?
I can go again if you
Sorry.
want.
Good question, yeah.
Well, storage is equally important.
Yeah,
I would
fair enough,
put
yeah.
demand response and storage together in a way on this. Yeah, a very important role. It's already playing an important role. So we do have kind of, let's say, aggregated demand response units operating in the electricity market, and they are providing a response when, let's say, the situation gets tight. It's an example, I think, as Hannah says, of where we have the technology to make this happen, particularly with large industrial consumers. So, absolutely. I guess where there's still a gap towards implementation is probably seeing the rollout of smart meters, but there needs to be an accompanying kind of smart grid, let's say, to go with that to realize that demand response potential. But huge potential when we start to see these electric vehicles being rolled out or hopefully adopted by consumers. But again, that's back to the social science, so big element. But
Absolutely.
Maybe Hannah has more to say. Yeah.
Absolutely. Thank you. And I'm just going to highlight in terms of we've been talking about trying to get more people involved and have that wider stakeholder engagement. There's a great prod there from Lisa around the challenge program, which is running right now. It's a perfect vehicle to actually be able to exploit some of this research and engage with the end users, bring in the social sciences and the humanities research into that. So I would encourage you, if you haven't engaged, to get involved. So that's all we have time for today. So I'd like to thank our panel for joining us and talking about the research. Hopefully it'll stimulate some conversations that happen over the time down at the summit. So first, a round of applause for our panel today.